The curve with this equation has a stationary point at P. It is given that P is close to this coordinate here, 2.4 minus 1.6. Find an expression for dy dx. Show the x-coordinate of P satisfies the equation here. By first using an iterative process based on the equation in part 1, find the coordinates of P, giving each coordinate correct to 3 decimal places. So let's have a look at this question then. So let's get dy dx then for part 1. So here, dy dx then is equal to, it's a quotient function, so we use a quotient rule. I put a bracket because there's more than one single object, so I'll put it in a bracket. So it's v du dx, which is 3, minus u, more than one term, put a bracket, times the v dx, so 3x squared, more than one term of course, put a bracket, minus 8x, and the constant goes to nothing. So that's v du minus u dv, all over v squared, this object squared. Okay, that's dy dx then. So stationary point is when dy dx is 0. So here, oh no, I'll just put at P, I think. So at the point P, we know dy dx is 0, and that means the numerator must be 0. So 3 of these. So I'm going to run through the 3 through the whole of the bracket. 3 of these. 3 of these is plus 6 is equal to, now this whole thing equals 0, but I can move this over the equals and flip this minus and move this object over and expand the bracket at the same time. So it'd be 9x cubed minus 24 x squareds, then plus 12x squareds, and then 4 times 8 is minus 32, isn't it, x. So if we look at the x cubed then, we've got a 3 here and a 9 here. So if we move the 3 over the equals, it becomes minus 3. 9 take 3 is 6, so we've got 6x cubes. Now the 24 is minus 24 plus 12 is minus 12x squareds. We've also got a minus 12x squared on this side, so they'll all cancel out. And it just remains for us to move this 32x over to be with the 6, isn't it? So this moves over to plus 32x. And we can leave the plus 6 as is. So that's what we've got then. Now we can move the 6 from times down to divide. And I'm going to read it from right to left. So move the 6 down to be underneath. 32 over 6 is the same as 16 over 3. Lots of x. 6 over 6 is 1. Cube root both sides, and we get the cube root of 16x over 3 plus 1, which is what we wanted. So now we know the initial value is approximately 2.4, and it says use an iterative process to find the coordinates of P to 3dP. So let's have a look at that then. So here then, in this case, we're going to have an iteration formula. X to the n plus 1 is equal to the cube root of 16x to the n over 3 plus 1. And our first value we can start off with is x0 is 2.4. So let's try that in the calculator then. So let's get the calculator. We want 16 bracket 16. Oh, cancel first. Put 2.4 into the answer here by pressing equals. 2.4 equals. And that will give us in memory under ants. Then we want brackets. 16x over 3. 16 times ants divided by 3 plus the 1, close bracket, power 1/3, wasn't it? 1 divided by 3. Okay, let's see what we get then. Equals 2.39861. So x1 is equal to 2.39861 x2. Let's just tap that in the calculator. So all we need to do now is that number will still, because it came up as an equals, it'll be here, so we'll just press equals again. And we'll get 2.39818, 2.39818. Let's try x3 now. Get the calculator, press equals again. 2.398048. And then let's just do one more. It looks like we've got our 3DP answer here. That's 2.398. So let's try one more. Yeah, it's 2.398. 2.398007. So to 3DP then, it looks like the answer is going to be, so x at p is 2.398, and that was to 3 decimal places. So if we go to our calculator, let's just verify that by just going back here. If we put in 2.398 instead of the answer, 2.398, it should output again 2.398. That would be 2.398, wouldn't it? And if you press equals again and again, it's always going to be 2.398 to 3DP. That's fine. So what is the y coordinate? Well, we need to work that out, don't we? So we need to go back here to get our formula for y, to verify the y value, because we need the coordinate to 3DP. So it's 3x plus 4 at p. Y is equal to 3x plus 4 all over x cubed. Remember what it was? Let's go and get it. Minus 4x squared plus 2. Minus 4x squared plus 2. And the input value is 2.398. Here and here. So that equals, tap it in the calculator, so it's 3 times 2.398 plus 4 equals, we get that number, and that's divided by then the number underneath, bracket, so 2.398 cubed power 3 minus 4 times the number 2.398 squared, and then plus, and the number was 2, put that over there, plus 2, close that bracket, equals minus 1.552. And that's also to 3 decimal places when we put the other x coordinate into 3 decimal places, so that should be fine.